If you ever wondered how games like Minecraft, for example, make transitions between the biomes so the grass looks like this, not like this, you just find the right video where I will describe you the logic behind it, and I will also show you how you can implement the logic in your own Godot game. And the answer for question how it is obtained is I always hated writing shaders, but take a look how my games which I created with Godot looks without any shaders and how it looked now when I enable shaders with color gradients based on biomes and overlays. My game uses few different shaders, but today I will show you how to make your grass look slightly different in different biomes by implementing color changing and smooth gradient. Let's begin. You will need project in Godot 4.3 or newer. This is because I use tilemap layers. You can also use this in the old tilemaps, but I want to keep this video up to date with the latest version, so I use tilemap layers. Empty tile for representing biome, and tileset for grass. They can be with drawed edges, so you can also learn how to preserve the edges and change only the main colors of these tiles. I will use grass from my old game, Astro Strike. What you are doing here, go check the website. Next step is to set up a tileset. So create new resource in the file system, search for the tileset, create, I will name this just a tileset. Let's drag and drop biome tile here, and yes, we can automatically create tiles. And the same for the terrain PNG. And let's start with biome tile. We will go with 3 types of biome. Let's select this, the only one tile here, and right click it, create an alternative tile. And now we can click on the plus icon. Now we have 3 tiles. Let's select the first one. In the rendering, we can modulate this. I want to create 3 biomes depending on the climate. So let's go with warm climate, dry climate, and wet climate. So let's, for example, make this as the yellow one. You can select the colors you like. This will be only displayed for us. We don't want to display this to the player. And now let's go to the alternative tile, first one, and let's set it as red. This will be warm, dry climate, where our grass will be more yellow than green. And the last one, the wet, you can go with the blue one, wet climate, and the grass here will be a little bit greener than in the standard climate. Okay, but these are only the colors which will tell us what biome is where in our tile map, but we also need to have an information assigned to the tile, what biome is this, and we can use the custom data layer. So here in the inspector, if you have tiles selected, you can go with custom data layers, click on the add element, type of this will be string. We will just write string names of the biomes, and let's call it biome. Now in the tile set, when you click on the tile, in the custom data biome, you can write a name of the biome. So this will be warm biome. As you can see, Godot write this information on the top of the tile, but this is not visible when you place tiles on the tile map layer in the editor. This is just visible in the tile set. This is why we go with the different colors also. Here we have dry, and here we have wet. Okay, so first tileset is set up properly. Let's go to the terrain. Now we need to create a scene. Let's go with 2D scene, and let's name this world. Let's save this as a world tscn, and this will be our starter scene. So right click on it and set as main scene, and I play this, and okay, we have our empty scene. Let's back to the world and add child node. Let's go with tilemap layer, not tilemap. Tilemap is deprecated since Godot 4.3. Let's go with tilemap layer. This is the new tilemap system. Create this. And the first tilemap will be the biome tilemap. And let's create another one tilemap layer, but not as a child of biome, child of the world. Let's name this grass, because this will represent the grass. Here in the biome, in tileset, we can go with quick load and select our only tileset. And the same for the grass. Quick load, tileset, And voila. Now in the biome, I need to draw some types of biomes to the scene. I will go with this blue rectangle area. I want to fill part of it, so you will be able to see this without creating any additional cameras. I will just use this default screen. So let's select tile map here on the bottom, biome tile, and let's go with our default biome. Let's set this area, for example. Now I want to have some warm area. Now the wet area at the bottom of the screen. And to make this a little bit more interesting, I can sharpen some edges. Okay, so we have some sharpened edges here, some floating single biome tiles here. This will just represent the color on the grass, so you can add these ones here because they will be not shown and they will be just mixing the visual layer of the grass. Now let's go to the grass, and in the terrains I need to set up grass, and I will add also some sand on the edges. Okay, we have our grass with some sand here in the corner, so you will see how the edges looks after applying shader. Okay, so we have our tile map set, and now we need to write some scripts and shaders. And let's start maybe with the shader. To create new shader, go to the grass node here in the scene view, and to the material in the inspector. Click on the empty material and create new shader material. And here in the shader, in the empty, we need to click new shader, and let's name this shader grass shader, for example, because this will work only for the grass. And to edit this shader, we can double click on it. And at the bottom of the Godot and shader editor opened, and we will see our file here. But we don't have too much space here, so we can click on this expand bottom panel. We will have this editor opened for the entire editor, and you will be able to see more content also. Okay, let's get rid of this slide function here, and we can remove the comments. Okay, and let's start with creating const of the type vec2 tile size. This is a size of your tile, the same size you defined here in the grass tile set, tile size 1616. We need to write this to the shader as a constant, so we can calculate some sizes in the future. So let's create vector2 16 per 16 pixels. We can also add a uniform bool enabled. This is just a switch which will enable or disable your shader. It is sometimes useful because you can scroll to the shader here, the shader parameters, and turn it off when you don't want to see it. Next uniform, vec4, color from, and we want to use a hint source color, for example. I will show you how it looks, color from, and you can use this to select the color. We will set this from the script, but this can be useful sometimes to pick a color from here. And vec4 because color is based on the red, green, blue, and alpha colors. We don't use alpha here, but the entire color is vec4, so I will start with vec4 here. And the uniform sampler 2D, color 2, and this will set the texture we will use to get the color we want to set in this tile. And this is sampler 2D because we will pass the image texture here, and every point of this image texture will represent one of the tiles on the tile map. Okay, and we need one helper variable varying vec2 world position. This will be needed to translate our world position to the color 2 image texture in the future, and we can calculate this world position in the vertex function by using model matrix and multiplying it by the vec4 of vertex 0, 1, and by getting x and y. I'll type here, position. Now let's go to the fragment. Because I use enabled switch, I will go with this if enabled, and we will write all the instructions here. Let's begin with getting our source color. This is a color which is used in this pixel originally in our original texture. So let's get texture from texture, UV. This is source color, so every pixel is checked in the shader, and then every pixel can be replaced. And when we have source color, we can also now calculate the local position, world position, divided by tile size. And now we can check the color, but it is a bad idea to just check if source color is equal to the color from, because colors are coded in the float variables, and because of that there can be little bit differences between them. So we will create helper function, let's call it color match, and we will pass vec for A, vec for B, these are colors, and toleration, and now we can check and return if distance between A and B is no more than tolerance. And this check if the colors are such similar as they can be the same. This is because we use color match function, and we can check if the color from is the same as the source color with the toleration, for example, 001. You can change this to a little less if you use many colors, but if you use just few colors on the texture, and this is probably okay. And now here, let's get the texture size, texture of our image texture color 2. This is the function to get the size of the color 2. And now what we want to do is to change the color of the pixel to the color from the color 2. So we want to set a color as the texture color 2 from chords, and the chords are local position divided by the texture size. If you, for example, want to have more calculations, then don't use color here. Instead of this, you can, for example, set source color.rgb to this value, then write RGB here also. And at the end, set the color to the source color. That way you can have multiple if statements here and make some calculations, overlays also in this shader, and then you will set the color at the end. So this is probably a little bit more useful. This is how I do this. So we have our shader ready. Let's close this shader editor and let's go to the Word, right click on it, attach script, and create a script Word. Okay, we can close this entirely. And now we need to have a helper GD script, which will communicate with our shader and pass some colors from the node to the shader. One more thing, I will write this script to work in runtime. So right after you play the game, it will calculate this in the ready function, set up the shaders, and the effect will be displayed. If you want this to work in the editor, you need to add the tool annotations at the beginning of this. So you can use this with a tool, or you can use this without. I will show how to use this without. Okay, so let's go with creating some variables. We need to have a variable biome of tile map layer type. This will reference to this biome tile map layer. The same for the grass. Also color from. This will be the color which we want to replace. This is similar to this color from here we created. We will pass this color from the script to the shader, and we will also want to create smooth radius, and we will start with 3. Now the color 2, this is the target color we want to set our grass to. And because we have 3 biomes, we can have the grass in the default color, in the more warm, so the grass will be a little bit dry, and in this wet, it will be a little bit greener, for example. So we have 3 biomes. Let's go back to the script. Default is specified in the color from, so we want to specify the colors to the dry and to the wet biomes. And to do this, we need to write the color. Here you can specify it as a HTML if you set this in the hex code, or you can just write the value. And these values, I have them prepared in real, so I can use them in the tutorial. And this is what I will use to the dry. You can write RG and B. Alpha is the default 255. You can write this, or you can only do fun. You just need to check, try, and get values that will fit your tile map. You can do this for hours before getting the value you want. Let's go with function ready. I will calculate all the things here in the ready function because my tilemap is relatively small. But keep in mind that calculating this can take a while. So if your tilemap is big, it's probably good to have another function which will calculate this somewhere in the background, so you don't have a lag after starting the game. We need to create variable rect, and we get this by using biome get used rect. Now let's create biome image create empty. Width of the image is rect size x and height is rect size y. Then we don't use mipmap, so false. And at the end we use the format image.format rgb8. Typo here. We're going by the rows and by the columns, and we get every tile in our tile set. This is code of the tile we are currently in this for loops. Let's now check if we need to check if the cell really exists, because we can have a rect, but in this rect we can have some empty tiles. So we need to check if the tile is really occupied by the tile, or is it just empty part of the grid. Let's create biome cell. This will be the type of tile data. And from biome tilemap layer, we get cell tile data in the coordinates from the variable above. And now from this cell, we can get the ID from the biome. This ID we specify here in tileset, here in custom data. So we need to write biome cell get custom data, and the name of the layer of the data is biome. Here, if the cell is not exist, if the grid is empty in this place, we will get an error. So to avoid this error, we need to check if biome cell is not null. And if it is not empty, this will set our biome ID to the biome it has, and else we can write just null. We will know that if the biome ID is null, that means that we don't have a cell in these specified coordinations. Okay, now let's go the color we want to use for this cell. So from the color tool, we want to get the color we want to change in the biome ID. So this function gets color from this dictionary depending on the biome where the cell is placed. But as you can see, we have dry and wet here, but our tile can be in our default warm biome also. So as a second argument, we will specify color from. That means that nothing will change. So in the biome image, we need to set the pixel at the coordinates x and y to the color from the dictionary. In the grass tile map, we need to set the materials shaders parameter, so set shader parameter, and we need to set color 2 to the target color, so to the biome image, but we need to change it from the image to the image texture. So we need to write image texture that create from image and put the biome image here. And as I said, I want to pass color from to the shader also, so we need to write grass that material set shader parameter color from to the color from variable. Let's save this and let's play the game to see the effect. Okay, we have a problem here. This is because I forget to set references to the biome and grass in the word. So let's select biome, let's select grass, and we also need to select the color from. So we click on the color from, get the color picker and set this to the default color of this grass. Now we can play the game again. Okay, as you can see, color of our grass changed, so it works, but it works because our tilemap layer is placed from the 0, 0 corner here. I will show you how to fix this, because we don't always use tilemaps from the 0, 0 point just in the right and bottom direction. In my game, I also use it to the negative x and y. So to avoid this error, go to the script, or maybe we will just start with the shader. So go to the shader, and in the shader create another uniform vec2, and this will be the tilemap offset, and we need to use it here in the local position, or position divided by tile size minus tilemap offset. And that's all in the shader, but we also need to change this in the script. So let's back to the word ready function. After passing color from and color to, we need to pass another one parameter, grass material, set shader parameter, tilemap offset, and the value is just rect that position. But this is how it looks without smoothing. So it has a little smoothings here, but it's no big deal. If you want to get rid of this, you can set color to the filter nearest. Now when we play this, you will see that this is just square. So we have a little bit smoothing by using filter linear or just leaving this without any filter because linear is the default. We have a little smoothing, but it still looks a little bit strange. So we will do one more thing in our Word script. We will create a function named smooth biome texture, and we will put image as the parameter, and the radius default will be 3, and we will return the image texture. Now, I don't want to explain every line of this smoothing function because it just takes few tiles, it just takes few colors in the radius you specified here, get an average color of it, and put it as a target color in the new image texture. So I will just write this script, just use this script if you want to use the smoothing function in your shader. It's very easy to get lost in this function, so pause the video and check if every value is correct in your script. Okay, when you have this function ready, let's back to the ready, and here in the color 2, we need to delete this image texture, and instead of this, we will use the smooth biome texture passed with the biome image, and as the second argument, we will use the smooth radius. Smooth radius is our exported variable here. Let's save this and run it. So we have smooth terrain now, and in the Word, you can change the value of the smooth radius here. So now we have a smooth radius set to the 3 here in the Word. Let's start the game. This is how it looks. Now let's set this to the 0. Save this and restart. This is how it looks with the 0 smooth radius. So this is the same effect as we don't use the smooth radius at all. And now let's set it, for example, to the 10. Okay, save and start. And this is how it looks for the radius of 10. So the bigger value you put here, the more smoother terrain will be. But if you put this to too much, you will see that the calculation can take a little bit longer because we need to have more iterations. So the first one is the performance. With using too much smooth radius, you will impact performance. And now you also cannot see where the biomes is beginning and ending. It is cool because here in the right top corner, we see that the grass is a little bit drier, and on the opposite corner, we have a little bit darker grass, but you can see the borders of every biome. So for more examples, something like 3, 5, or 7 will be probably enough because you have a smooth variables between the biomes, but you can see the borders between the biomes. Okay, so that's probably all in today's tutorial. Let me know if this was useful. If you like shader tutorials, let me know in the comment sections, because lately I really started using shaders in my game, and I can share some ideas with you if you are interested in it. Hit the thumbs up if you like the video, and subscribe if you want to see more content in the future. See you soon in another video. Bye!